Hi, Honors Algebra 2 students. This is the lesson for day 13, and in this lesson we're going to be solving 3x3 systems of linear equations. What we mean by 3x3 systems is the fact that we have 3 equations and 3 variables. We'll be solving the following systems of equations algebraically, and you should be doing this with no calculator. All right, so we're going to use the elimination method to solve the systems that we're working with today. And when we do that, what we need to do is take 2 equations at a time, any 2 of the 3, and focus on eliminating one of the variables between those 2 equations. So what I mean by that, let's say in this first example, we work with the first 2 equations. If we multiply the second equation by 2, let's write out what we get. First of all, I'm just going to copy down the first equation. So 2x plus 3y minus z is equal to -1. And then if I multiply everything in the second equation by 2, I get -2x plus 10y plus 6z is equal to -20. And if I go through and add the equations, my x term goes away. I get 13y plus 5z is equal to -21. All right, so we haven't solved for any value of any variable yet, but we have eliminated one of the variables. We eliminated the x variable between those 2 equations. All right, so now to continue in the process, since we started with eliminating the x variable first, in order to get somewhere, I need to pick 2 different equations and eliminate the x variable in those 2 equations. So initially I picked equations 1 and 2, so I can now pick 1 and 3, or I can pick 2 and 3. So I'm going to choose to pick 2 and 3. And so what I'm going to do now to eliminate the x variable, I'm going to now multiply the second equation by -3. And when I do that, I will get I need to multiply by +3, not -3. When I do that, I will get -3x plus 15y plus 9z is equal to -30. And I'll copy down the third equation right below it just so we know which equation we're working with. Keep everything nice and organized. All right, when I add those equations together, indeed the x variable does go away. Those terms go away once I did my little adjustment with multiplying by +3. And then when I add those equations together, I get 14y plus 3z is equal to -25. All right, so I was successful in eliminating the x terms from that second set of equations. So now what I'm going to do to continue making progress with this, I'm going to take the 2 resulting equations that I got. So 13y plus 5z is equal to -21, and then 14y plus 3z is equal to -25. And now we're down to 2 equations, 2 variables. You know how to solve a system when we have 2 equations and 2 variables. You've been doing that for a long time now. So to eliminate one of the variables, and again, it doesn't matter which one, but I think I'll focus on eliminating the z. I'm going to multiply the top equation by -3 and the bottom equation by +5. So let's write out what I get when I do that. So I will get -39y minus 15z is equal to a +63. And then in the bottom equation, I get 70y plus 15z is equal to -125. All right, if I add those together, I will get 31y, the z term goes away, is equal to -62. If I divide both sides by 31, I get y is equal to -2. All right, so finally, after all of that, I've gotten somewhere. In other words, I have gotten the y value solved for. So now I need to start to work my way back, so to speak. And here's what I mean by that. All right, I know my y value is -2. So I need to go back to one of my equations that I've been working with, where it was just a 2 by 2 system. And I need to plug in that value of y equaling -2 so that I can then solve for that remaining variable. So let's say, for instance, I go back to this, this equation right here, this 14y plus 3z equals -25. So if I go through and I plug in a -2 for y plus 3z equals -25, I'm going to get -28 plus 3z equals -25. If I add 28 to both sides, I get 3z is equal to 3. So z is equal to 1. All right, I'm almost there. I have 2 of my values solved for. I need to move this up so I have a little bit more space here. All right, and then to solve for the remaining value, I still need to solve for x. I need to go back to some equation that has an x in it and plug in the values that I do know and solve for the x value. So I could go back to any of the equations, okay? But I think I'll pick the middle equation up here from my original system of equations. I'm going to go back to that. So I'm going to have, I'll squeeze it in right here, -x plus 5 times my y value, which is -2, plus 3 times my z value, which is 1, is going to be equal to -10. Let me put a little squiggly line in here so we can separate that. All right, so we get -x minus 10 plus 3 equals -10. So we're going to get that -x equals -3, or simply x is equal to +3. All right, so to put all of this together, a solution to a 3 by 3 system is an ordered triple. So don't forget your parentheses. My students have heard me say that. My x value is 3, my y value is -2, and my z value is 1. And just like any system of equations, if you plug that solution into all 3 equations, it should work. If it doesn't work in all 3 equations, then that is truly not the solution. All right, now before we go to the next example, I do want to summarize what we did. You truly can start with picking 2 equations and eliminating any variable that you want. But once you've put a stake in the ground and eliminated whatever variable you picked, for instance, I picked x, then your next step should be to pick 2 different equations and eliminate that same variable. That will then give you the ability to do is take your 2 new equations, set that up as its own system, and you'll be down to a 2 by 2 system, and then you'll know what to do from there. And you'll get the value of your first variable. And then you need to work your way backwards. So once you get the value of that first variable, go back to one of your equations in your 2 by 2 system and plug that in and get the value of a second variable. And then once you know the values of 2 of the variables, you work your way back to one of the 3 by 3 systems to solve for the remaining variable value. And then final answer, write your answer as an ordered triple. All right, and in our second example, we still have a 3 by 3 system, 3 equations, 3 variables, but you will notice that some of the equations do not have a particular variable in it. So for instance, the first equation doesn't have a z term, and the second equation doesn't have an x term, and the third equation doesn't have a y term. So it is missing some of the terms, so to speak, but it's still 3 equations and 3 variables. And the overall process is the same. You're going to pick 2 equations to start with, and you're going to eliminate one of the variables in those two equations. So I'm going to pick the first two again. You don't have to pick the first two, but that's just what I've decided to do in both the last example and in this example. So I'm going to multiply the second equation by -2. So I'll write the first equation, so I have it. And then if I multiply the second equation by -2, I'm going to get -4y. What have I got here? Minus 6z is equal to -16. And then if I add those together, the y terms go away. I get 3x minus 6z is equal to 3. And then if you notice, just so happens, this second or third equation, is missing a y term already. So I can immediately pair up my new equation right here with that particular equation. But remember, the goal in the next step in the process is to pick, another set of equations, so to speak, and eliminate a variable. Well, I'm missing a y term here now anyway. I already eliminated it, and it just so happens that this one does not have a y term either. So a good idea then would be to, let's just write the third equation right underneath here. All right, and then I guess I'll write the new equation that I had, just to show this that I'm in the second step in the overall process. And now, as you can see, I've got a 2x2 system there, 2 equations, 2 variables. And again, you know what to do when you get to something like that. So let's say I decide to eliminate the x variable. Let's say I multiply this equation by a -3 and this one by a +4. All right, so I'll write it over here. I get -12x plus 15z is equal to -21, and 12x minus 24z is equal to 12. All right, so I get, when I add those equations together, I get -9z equals -9, so z is equal to -1. Actually, that'll be a +1, right? All right, +1. All right, so once I have one value solved for, then I'm going to start working my way back. So I'm going to go back to this system right here, because then that will give me the ability to solve or to plug in a 1 for z and then figure out what y or x is equal to, and then I can work my way back. So if I continue on here, and you can pick any equation. I'll just pick this bottom one right here. All right, so I'm going to have 3x minus 6 times +1 after I made my correction. 3x minus 6 equals 3. 3x equals 9. So x is going to be equal to 3. All right, and then finally, I need to solve for y. So I need to go back to an equation that has a y in it, and I can go back to any equation that has a y in it. So if I look back at my original system, so to speak, I've got 2 up here that have a y in it. So I'll just pick the second one, I guess. And I'm going to go over here to the right so that I can have space. But I've got 2y plus 3 times 1 is equal to 8. So 2y is equal to 5. Y is equal to 5/2. Leave it as a fraction. We don't want or need the decimal. All right, so if I collect all of my values and write them as an ordered triple, my final answer is going to be 3, 5/2, 1.